Welcome. In the world of chemistry, getting things just right is absolutely everything. But that raises a big question. How do you possibly measure something that you can't even see? Well, today, we're going to master titration, a technique that lets you do exactly that.
Okay, let's really frame the problem here. Imagine you've got a solution of acid, but you have absolutely no idea how strong it is. How on earth could you measure its concentration accurately? It seems impossible, right?
The answer is this really cool process called titration. The best way to think about it is like chemical detective work. We take a solution where we know the exact concentration, that's our main clue, and we react it with our mystery solution to uncover its secrets. So before we even think about grabbing our lab coats, let's break this down. What is titration really all about, and why is it such a cornerstone technique in the lab?
At its core, the goal of a titration is actually pretty simple. We are trying to find the exact volume of our known solution that we need to completely neutralize our unknown solution. We're looking for that perfect point where the acid and the base have totally canceled each other out. It's all about finding that perfect chemical balance.
All right, like any high-precision job, you can't do it without the right tools. So let's gear up and take a look at the essential lab toolkit you're going to need for a successful titration. Okay, here are the stars of the show. The burette is this amazing piece of glassware that lets us add our known solution drop by super precise drop. The pipette lets us measure out a perfect, fixed amount of our mystery solution, and the whole reaction happens right there in the conical flask. Our chemicals, an acid and an alkali, which is kind of the chemical opposite of an acid, they do the heavy lifting. And the indicator? That's our secret weapon. It's going to tell us exactly when the reaction is finished.
Now hang on, before we go a single step further, we have to talk about safety. The chemicals we're using here, they're irritants, and they can be corrosive. As chemistry teacher Paul Roberts points out, any spills on your skin need to be washed off immediately. And any contact with your eyes, that's a serious medical situation. This is exactly why wearing eye protection is completely non-negotiable for this entire experiment.
All right, we've got our gear, we've had the safety briefing, it is time for the main event. Let's walk through the titration procedure step by step.
So this is the whole process in a nutshell. It all starts with really careful preparation. Rinsing your glassware isn't just busy work, it's vital for getting rid of any gunk or air bubbles that could totally mess up your measurement. Once you're set up, you add the indicator, and then you start adding your known solution to the unknown, swirling the whole time. The entire experiment, the whole game, hinges on stopping at the exact moment that indicator changes color for good. That final volume you added, that's called the titer, and it's the golden piece of data we're looking for. Okay, a quick pro tip for you, especially when you're using that pipette. It's so tempting to try and force out every single last drop of liquid. But don't do it. Pipettes are actually designed and calibrated to leave that tiny little bit of liquid in the tip. If you force it out, you're adding too much solution, and that'll throw your results right off. Just touch the tip to the side of the flask and let gravity do the work for you.
So picture this. You're swirling the flask. You're adding the acid from the burette drop by drop by drop. You know you're getting close, but how in the world do you know the precise moment to stop?
Well, it all comes down to our little friend, the indicator. With something like methyl orange, your solution starts out as this clear orange color. As you get really close to the end, you'll start to see these little flashes of pink that appear and then disappear as you swirl. What you're looking for is the single drop that makes the entire solution change to this delicate, permanent salmon pink color.
And this slide just says it all, doesn't it? It perfectly shows the difference between a great result and a bad one. That beautiful salmon pink on the left, that's the perfect endpoint. But if you add even just a couple of extra drops and it turns into that darker rose pink on the right, well, you've overshot it. You've added too much acid, and unfortunately that result is now totally unusable. Precision is everything.
Okay, so you've done it once. You nailed that perfect salmon pink endpoint. Awesome. So, we're done, right? Well, not so fast. In good science, a single result is never, ever enough. We need to aim for true accuracy.
So here's the really crucial point. You have to repeat the entire procedure. Doing it once just proves you can do it, but doing it multiple times and getting nearly identical results, that proves your technique is consistent and that your measurement is truly reliable. And there's a fantastic scientific term for these good, repeatable results. They're called concordant results. This is the gold standard you're shooting for. It means you've done the experiment so consistently that your titers, those volumes you measured, are almost exactly the same each time.
So what does very close actually mean in practice? Well, generally speaking, your target is to get at least 2 titers that are within 0.2 cubic centimeters of each other. Once you've got that, you can feel really confident about taking an average and using that value.
Whew, okay. That was a deep dive into technique and precision. So let's zoom out for a second and just lock in the mission-critical points that you absolutely need to remember. Think of this as your pre-lab checklist. Your mission, to find that unknown concentration. Your special tools, the ultra-precise burette and pipette. Your #1 non-negotiable rule, eye protection always. Your critical moment, spotting that first permanent color change. And your proof of a job well done, repeating until you get those beautiful concordant results. Get these things right and your data will be rock solid.
And there you have it. You have mastered the hands-on technique, you know how to dodge the common pitfalls, and now you have a set of beautiful, reliable, concordant results. You know how to do the experiment. So the final question is, what story do those numbers actually tell? Well, that's where the calculations begin.